Hi, good afternoon, everyone. Nice to see you all. Welcome. And I'm Terence from HKUST Entrepreneurship Center. Nice to meet you all. And first, I would like to say a big congratulations to you all because you have formed a team to continue this process. This is not a given. Some of you maybe apply with a team, but I know some of the participants couldn't form a team last night, so they cannot continue this process. So you have actually reached a major step. So congratulations. And I hope you all enjoy this week to work closely with your team, and more importantly, challenge each other and struggle together. This is only going through hardship is the best team building exercise. So I really hope you enjoy the coming week. And talking about struggle, I would say that one of the major challenges for every startup is to convince others or prove others that what you have in mind actually works. And there's a lot of steps you have to take, but I think one of the most essential one is to build a prototype, to show others, to demo, and make sure people see what you mean. And yeah, so I know you may say you only have 1 week. How can you build a prototype? For this question, I have 2 points to respond. First, we are all innovators. We always should look for innovative ways to make use of the resources we have, including time. So, and there is actually a lot of different tools you can use to crank up a simple prototype in very short time. And second, I would also very encourage you to look beyond this week. So who knows, maybe after this week, you actually love to struggle with your teammates and decide to stick together. Going forward, afterwards, you continue to build more comprehensive prototype and even step by step, a very successful product and build the foundation of your company. So to help you achieve this, we are very happy to have Professor Terence Wong, Assistant Professor in Department of Chemical and Biological Engineering in HKUST, to share with you a few tips of how to realize your innovative idea into making an actual prototype. And I have to tell you, Professor Wong is an expert in this because in addition of teaching and researching, he is also founders of 2 companies, 2 startup companies, who both of which are currently HKUST incubation and doing very well. And so just let me pass the time to Professor Wong, and so that we can take his brain on how to make it as an incubator. So, Professor Wong.
Okay, so thank you, Sarah, for the very kind introductions. Saying that very success. I don't take this for now, but hopefully, one day I will also admit that it's very, very successful. So as Sarah mentioned, I'm an assistant professor at HKUST, and also I serve as the associate director of these HKUST research centers for medical imaging analysis. And currently, I have also 2 posts for the commercial side, 2 companies. One of them are like the founders, but the other one I would say is the co-founders as well. So I pretty much will share with you all about this journey. Okay, so because it's indeed a relatively long sharing, it's about 1.5 hours, right? I seldom actually have this kind of long sharing. Okay, so I will break this part into a few parts. The first part is sharing of my own journey. Okay, I believe later on you'll find out that these journeys, although we would have very different journeys, but then at the very end would be also similar in terms of the structures. Because as Sarah mentioned, you will struggle and you refine your ideas, and then later on make a real prototype or better prototype and forward. Okay. So I will share with you my journey starting from like undergrad, PhD, and then assistant professor, and I right now having companies like entrepreneurs. And I will share one of the company story only because otherwise probably too long the story. Okay, so I only share the story about PhoMedics, And I will switch the gear to talk really the big part of today is about prototyping. Okay, how can you really make it? Okay, can you make it? And hearing this, I will also give you a little bit tips from prototyping to product. What's the further consideration you need to take? Okay. And last but certainly not least, I was told many of you maybe in the future want to join Hong Kong Science Park, Science and Technology Park, HKUST, to be a entrepreneur there. Okay, so I also want to give you some tips or information items, such that you can join the program and grow there. Okay, there are indeed two very generous programs. The first one is a pre-incubation called ideation. I believe many of you probably know, because if you win in this hackathon, you basically directly fast track to this ideation. It is a pre-incubation program, and you can further polish your idea to a level that, wow, it's really making a game-changing idea. And the other one is more, I would say, is a bit more mature. It's really incubation, not pre-incubation. And there are two types. The first one is incubation, and the second one is incubate. But both of them are incubation programs. So my first company, PhoMedics, has joined Incubio, and we have another company is going to join incubation instead. Okay, so at the very end, I will have a very, very long Q&A. Okay, so because why is that? First of all, I don't fully trust whatever I say you can take it. Because lecture delivery may not be very, very efficient. I want you to ask questions. And although I put the schedule like this, feel free to stop me anytime. Okay, I don't mind, I skip some of these, I don't mind. But I want you to learn something, take something from these sharing. Okay, hope that is clear. All right. Before I start my journey, I want to let you know my background. Okay, I was born in Hong Kong, all the way from kindergarten study to MPhil. Okay, undergrad I did it in Hong Kong U, MPhil also in Hong Kong U, and then I thought that, wow, I want to be a professor sometime. Somehow I want to be at that time. So I believe I want to study overseas to really polish my skills, research, better academic achievements, so that I study overseas for my PhD degree in the States. I joined both Washington and Caltech for my study because my supervisor got invited from Washington and Caltech, so I moved with him. And finally, after my first PhD graduation, I joined HKUST as an assistant professor, and now I've joined roughly 3.5 years now. Okay, time flies. And just one more thing about me is I basically developed tools, medical imaging tools that can save patients' lives. Okay, that is what I have been doing. Okay, so let's get started for my journey and see what I did during my PhD work. All right, so one medical problem I have been heavily working on during my days in the States is called margin analysis. So how many of you know a little bit about margin analysis? Raise your hand. Oh, stops. Stops? No. Not really. Okay, it's about medical problem like cancer. Okay, so forget about these slides first. So let's say I have tumor, I have cancer, so unlucky. What do I do? Do you know what do I do? I just stay at home and cry. Go to see a doctor. What's next?
They stay with your hospital and
okay, all right, good.
if was not
Banana tumor, and then what happened?
if you take a tumor, then there will be no help.
No help. Okay, so that's pretty so early. All right. So pretty much about this status, I mean, the journey is that you likely will go to hospitals, and the doctors, medical surgeons will help you to harvest the tumor out. Okay, get the tumor out. Try his or her very best to remove all the tumor. Okay, and your classmate, teammate, okay, somehow maybe he found a team here, said that if it's like that tumor, and that tumor, then you are kind of unlucky. Okay, that's pretty much the journey. You have to really harvest the tissue and try to see if it's, and then you may have different treatment. But during this harvesting process, there could be two stories happening. Could be the one on the left, your left, right. But people, I guess, also on the left. Negative margins. Negative margin, by the way, the blue dashed line here is what the surgeons did. I mean, the area that they cut. So you see the tumor or the cancer cells are well encapsulated by normal cells. This is really what we call a good surgery, negative margins. What's problematic is on the right, positive margins. Because after the surgical cut, there are still some cancers remain inside the patient body. And what even worse is, around 20% of the patients going through this what we call conserving surgeries indeed have this kind of problem. I mean, ending up with positive margins. If you end up with positive margins, guess what? What should you do? Let's say I am the really unlucky person. Go for a conserving surgery. I end up with the case on the right. What do you need to do? Do surgery again. Exactly. So do you want to do that? Likely not. Yes, for many of you. All right. So you see the problem. 20% of the patients have to go through another surgeries purely because of positive margins. Okay. So during my PhD study, we asked our whole team, can we have a better diagnostic tools to solve this problem? So solve the pain. Don't come back again. Patients, don't come back. I don't want to see you again. Okay. After the cut, go home. And in order to answer this question, you have to go through the journey of what's happening in hospitals. Okay. After harvesting the tissue, you have to go through what cross examination, patient and embedding, sectioning, staining, and analyzing. It's indeed a very lengthy process and involves many departments' efforts. Okay. So that's why this entire process, in general, guess what? How long it takes roughly? Any guess?
6 months.
6 months? Too long. Not that long. 2 weeks. Okay, more reasonable now, but it's still not the case anymore. Purpose is actually around a week, roughly a week. What does it mean? It means that after the patient is done for the surgery, he or she is actually home before they know the result. You follow me? Because it takes around a week. Okay, so that's why they have to really come back for researchers. If this process can be done within, let's say, 2 minutes, then you don't need to. Okay, follow the logic, right? So we ask ourselves, can it be done then? Can we start the harvesting the tissue and then somehow generating images that the one who are so professional seeing the images here are called pathologists, okay? Such that the medical professional pathologists can understand the images. This is what we want to do in a short time, okay? In a graphical manner, you can see that it's like harvesting tissue, somehow shining with lasers or sort of stuff, and generate images that pathologists can understand. Okay, it's really that simple. So this is what we proposed during my days in the States. It's called a UVPM system, ultraviolet photoacoustic microscopy system. So you can see it's actually not a very complicated system. It's not. It's relatively simple. But then it's really can achieve the goal that directly harvest the tissue, put it in, and we can get an image right away. Okay, so this is by the way a breast tumor. Okay, for those who may not have seen the breast tissue under your skin, this is indeed the case of your tumor. So we image the green dash line area, and this is the image that we got. Okay, so you can see when we compare with the 1 week test, the one that goes through the 6 steps is relatively similar when you zoom in. I guess you can see most of the features are relatively similar, although the color tone is different. Okay, so our pathologist, the one who read the images, and basically rely on our images only without cross-referencing to the bottom row images and make the same diagnosis. That's one of the biggest mission that they need to do or we need to do. Just want to remind everybody the bottom row, although it looks very great, very colorful, but at the same time it takes around a week to get. All right. Seems the story is very sexy. It seems that it works, but I have to break everyone's heart here. Is that at that time, although it seems it works, but at the same time, it's not working that well. Why do I say so? It's because guess how long it takes to get this gray, what we call gray scale images? That means this one. How long it takes? Although I said that I image it right away, I don't need to go through that 6 steps. I have the tissue, put it into my device, and I generate image like this. It still takes me 2 hours. Okay, so we shortened the process from 1 week to 2 hours, but it's still too long. Still too long. So what's next? And mostly, I guess, because of this work, I got recruited by HKUST as an assistant professor like back 3 years ago. And at that time, for those who can read written Chinese, for those who cannot, how many can you cannot? Or all of you can? All of you can, then I don't need to explain, right? Okay, quickly. At that time, I said that because of this press release, I said that in the future, with the integration of data science and also faster imaging techniques, I believe we can shorten the process to 3 minutes, from 1 to 2 hours to just 3 minutes. Okay. At that time, I said before you can enjoy a cup noodles, I can tell the surgeons whether he or she did a good cut initially. If not, do a further cut during the initial surgeries. Okay. Guess what? And after this press release has been out, after like 1 to 2 months, I have to admit that at that time it's just a concept. Okay, just a concept. And around 1 to 2 months later, a VC called me because they saw this press release. And then they asked me whether I'm interested in bringing this technology into the world. I mean, maybe putting it in the hospitals. And then I said that I just joined USD for 3 months. And I don't have resources, just a concept, and I don't have even students at that time. No one to really try it, implement. Okay, so I said that it probably will take me some time to prove that whether my hypothesis is correct or not. Okay, this is really the process of prototyping. Okay, and anyway, the simple message here is why I'm here. I guess many of you can guess is because we are almost there. And I'm very glad to share with you. This is what my startup PhoMedics is doing. Okay, so the product is called not really a product yet, but then we call the name of this device a CHEM microscopes. Okay, later on I will share with you why it's called CHEM. But it's an intraoperative cellular imaging device. So intraoperative means during surgeries. So if you can get a result during surgery. So let's recap one more time. We started with the surgeries, right? But I did not provide you the full picture just now. I said that the whole process takes 1 week. And this is not the complete picture, but rather there is a fast alternative called frozen section. A frozen section is really fast. It takes around 30 minutes. You can get the results instead of 1 week. Okay, bear with me. I will explain why I don't show you the full picture. And then if there is a positive margins, what happens? Go back to the situation that we had previously. If this positive margin is something that you don't like, right? Do further cuts. Okay, so this could be a loop. Another loop, could be another loop, it could be another loop. Until you finish up with a negative margins. Okay, or you repeat, right? This is one path. We still have another path. Here is the one we test. Why do we need to do this? It's because frozen section, although it's fast, but it's not accurate. Okay, it's fast, but it's not accurate. And this one we test is very slow, but it's very accurate. And why do we have second surgeries? The operation is actually the difference between these two. Follow the logic, right? Because frozen section say negative margins, then you can go back home. But the tissue we also resent to the 1 week test, saying that it's positive margins, so that you need to come back. Follow the logic, right? So this really kills the patient. I mean, really make us feel so painful. Yeah, obviously, right? You don't want to do that. You want to have a very fast, very accurate diagnosis. You don't want to do a second surgery, not to mention the waiting, the anxiety of waiting. Okay. All right, so frozen section is obviously one big pain point. Okay, pain point is a very important term in doing business. Okay, essentially you're trying to develop tools that can solve something. Okay, so frozen section is the pain point of this story. Is although like just a 30 minutes, it's also still includes a lot of different steps. Okay, so and again here what we can do is to by passing all these steps, by passing all these. Again, just harvest the tissue, put into what we call the chain microscopes, and later on hopefully can get a very good news. Yes. So fundamentally, how can you bypass all these images? Again, is to have a way to see the tissue. So how many of you study biology in high school? No? No one study? Oh, some of you. Okay. So for those who so how can I call you? Martin. Okay. So in biology, have you ever used microscopes? Yes, genius. So have you ever tried to image a pulp? Really? How thick is the pulp with a microscope? Do you need to thin slice it into a very, very thin layer before you can put it under the microscope? You need to. Why? Do you know why you need to make it a so thin slice? Magnification too high, and then you have to make it to be very thin. Close. And it's actually the microscope or our eyeballs is so good at doing integration. It will integrate whatever you see along this axis through the microscope like this. So in general, ordinary microscopes cannot handle thick tissue. Cannot. If you put a thick piece of pulp, you're out of luck. Everything you see will be very, very blurry. So that's why you need to make very, very thin slices. So that's one of the main mission for frozen section is to make very, very thin slices in a very, very short time because microscope cannot handle thick tissue. Is it clear? All right. So how about other imaging method that can handle thick tissue? That could be quite some. For Martin, what are you studying now? Business. Anyone who still insists to study life science in universities? No one raising up to raise your hand. Okay, all right. Have you ever heard of confocal microscope? None of you, no problem. That's why I'm an expert. Okay. So indeed, there are many technologies can image thick tissue, really thick. One of the options is called confocal. Another option is called stimulated Raman. Another option is called OCT, optical coherence tomography. Although you may not know them, you might have experienced them before. For example, like OCT is now used to check your retina clinically. Okay, whenever you thought that you have some retina disease, this is the tools that you're using, although you don't know. Okay, all right. So there are indeed some options, but then they also lack some or experience some difficulties. For example, you need very high power lasers, very high cost, and the resolution is not high. Okay, these seems to be okay in research, but then think about you want to commercialize the product, like what Cyrus mentioned. You want to make sure your idea can be realized. You only have a relatively short time. You won't pick the most sophisticated option for your choices, right? You pick the one that is accessible and you can reach easily and relatively cheap to test your idea, right? So this is also important when you try to make a product, because after all, business is business. If you cannot make profit, if your cost of your device is so expensive, you cannot earn any money. All right, so that's why we propose a new idea which would be cost-effective in nature, at the same time, it's also very fast. And this high speed, or the name is called computational high-throughput autofluorescence spectroscopy by pattern elimination. By taking the first letter of each word, we call Chang. Okay, I really like this term because, yeah, it's just so Chang. Okay, and instead of going to the details, because it's not an engineering lecture, I don't want to go to the detail. I want to give you some features of these microscopes to let you feel what's the importance of it. Do you remember we said that we don't want to cut the tissue into thin slices. We don't, but it's difficult not to. And this CHEM microscope can handle that. Okay, you really don't need tissue slicing. Put a thick one inside is perfectly fine. Okay, and there's also one step very important in the previous approaches is the staining part. You need to add some colors into it. Guess what? Cells in general is transparent. Okay, so that's why in the pathology lab, I mean, if you do study high school, you may need to add some color to the cell. Otherwise, they're transparent to you. So we also play with the colors that we can excite the cells, and eventually we don't need chemical staining and still achieve very high contrast, such that you can see this. And not only that, we also enjoy two more features, which I would say is very important features clinically. Okay, what are the two? First of all, let me have a follow one more microscope questions. So for those who have used microscope before, when you use very high magnification lens, what happens? You see a lot of details, right? High magnification lens, you see a lot of details. But what do you sacrifice? All good, perfectly fine. You only pay a bit more money. What's the drawback whenever you use a high magnification lens? Perfect. So this cartoon here is showing you the case. If you use a 4x objectives, low magnification, you can see much bigger field of view. Okay, but then if you switch to high magnification lens, let's say the 20x here, the field of view you can see will be much smaller. Okay, so this is a trade-off in general. You want high resolution, you sacrifice the field of view. Okay, but because of this pattern illumination, we break these rules. We break it. Such that what's the outcome is that you can enjoy a large field of view, at the same time you still see features clearly. Okay, for sure I'm not taking into the detailed physics and math, but then bear with me, this is the feature of these microscopes. And last but certainly not least is equally important, at least clinically is very, very important, is high tolerance to tissue surface roughness. I believe many of you, for those who think about microscope before, when you tune the C-axis, it's why C-axis. If you use a very high magnification lens, it's very sensitive and easily out of focus. Easily. And you might have this experience. Think about it. If we are dealing with some very thick tissue, it could be very rough. The surface could be very rough. You won't ask the doctors, hey, come on, Peter, you cannot cut thin slice. Forget about your surgeon job. No, you can ask the doctor to do that. They will just roughly cut it and put it into the microscope because it's so time-sensitive applications, right? So you have to have a technology that can accommodate these needs. Very high tolerance to tissue surface roughness. Let me show you these two photos here and this one. So conventionally, if you use a high magnification lens, you see some part of it is in focus, some part of it is actually out of focus. But then using these CHEM microscopes, the entire image before that is still very, very flat. Before that, although the surface roughness is still there, but we don't experience that. So clinically, it's very, very important. You save a lot of working effort in hospitals. All right. So I pass this because it's not a engineering lectures, but this is really the working principle of this pattern illumination. That's such that we can enjoy very large field of view and also very high resolution. So we have a very long Q&A. So if we are interested or you are interested, I can always come back, but I will skip for now. Okay, then we're here. This is what we call grayscale images. Grayscale. Anyway, okay, grayscale. So we are happy with this. But then remember, we are not the one who judge. The one who judge is who? Do you still remember the one who read these images? What do they call? No one remember. Huh? Perfect. Yes, pathologists. They are so used to what? Colorful images. So used to. And it's not a joke. Although it's colorful, the colors even matters. So pathologists normally don't really need to zoom in very a lot. They see the, I will show this story more later on. The colors really means a lot to them. It's not only for better visualization, also for fun. Okay, it matters. So we're engineers. Okay, we develop the tools with the leftmost column figures. And this is the user's needs. Remember, this is the user's needs. I will keep emphasizing user's needs in this sharing. Okay? If you don't know your user's needs, you can never make a good prototype. All right? So that's why we do this. Virtually stained deep chat images. So this involves some deep learning algorithm development. But then bear with me, the take-home message for each work, each step is to make pathologists' life easy. Okay, that's it. Nothing changed. Is to make their life easy, such that they don't need to learn more technologies. To them, it's equivalent. Okay, that's the take-home message for this virtual staining. We call it virtual staining. All right, so let me show you a video about what we can do for this virtual staining. So we try to play with different thick tissue, like this is a mouse brain tissue. The left row column here is the grayscale chat image. The middle column here is the gold standard, that means the one-week test. And the rightmost is our virtually stained deep chat images. So basically, you can scan whatever region, and we can generate real-time conversion of all these different colors. Yeah, maybe I can skip. It's just different regions. All right. So it seems to you that, wow, just seems like a plug and play. You just put some given algorithms in, and then you make it happen. Not really that simple. We have been putting a lot of efforts. So how many of you know a little bit about that deep learning? How many of you are computer scientists? I saw that you raised your hand. Martin, what is your major again? Oh, okay. How about you? Oh, okay. Which school you're from? Oh, okay. Good. All right, great. Then you must have heard of supervised and unsupervised learning, I believe. This is, I believe, is available worldwide. Many different places can provide you this kind of tool to do this kind of virtual stainings. But then, guess what? Remember, this is the ground truth that goes through when we test. This is the one we test result. And you will see what happened. These all grayscale images are chat image. All right. Give you 3 minutes. 30 seconds. Have a feeling first. I did not introduce this one. Okay, this one is what we developed in-house in my lab. Okay. All right. I guess it's clear. How many of you think the supervised learning is the best? Raise your hand. This is the one that you want to compare with. Okay. Raise your hand. For supervised learning is the best. No. Unsupervised learning is the best. No. Weekly supervised learning is the best. Yes. So obvious, right? And for sure, again, it's not an engineering sharing, so I won't go details why it happens like that. And if you're not convinced, I show you more solutions. Okay. So if you know a little bit of pathology, which I don't expect, at least you can see those little purple dots only correctly output in the supervised learning. But they are all mixed almost in both supervised and unsupervised learning. I really like imaging because I don't need to speak. I put it here, you can understand what. All right. So this is a breast cancer demonstration. We have more breast cancer images, and because we can't weekly supervise the tests, the following I will only show you the weekly supervised approach. And we all not only want to show that it works for breast cancer, but also want to show that it works for lymph nodes. Lymph node is very important because this is almost the channel for cancer cells to flow through around your body. Have you ever heard of metastasis? Metastasis? Not really. Or some of you, yes. Okay, that's good. Yeah. So leaf node checking is super important. If I block these two, okay, and I block the heading, and you tell me which one is which, very hard. Right? I believe many of you agree. And more importantly, still remember I said the colors matter. I said the pathologists really rely on colors. I can tell you before they show me seeing the features of these, they already know where are the tumors with the colors. Because in general, purple means cells, cell nuclei. If abnormally dense nuclei happen somewhere, in general, it's a tumor. Okay, so very chemical. And then forget about it. Just more data to show you. I will go through very quickly. Lung cancer also works. Also means to convince you further. All right. So what we envision in the future is this: in the operating theater, get the tissue out, put it into the check microscope, forget about process section, put it into the microscope, and we can remotely send the images to the pathologist. Okay, really the hero behind the scene. And at the end, this process can be compressed to 3 minutes. Okay, process section takes 30 minutes, and we can finish this whole process in 3 minutes. And not only that, process section accuracy is about 65%. And again, it's also because of this accuracy problem, which brings second surgeries happen. I mean, research. All right, and currently, according to our analysis, our accuracy should be as high as or even higher than 90%. Right? So, prototyping is the main message for today, right? So let me show you a prototype video. Hopefully, it will be useful during this journey or later on years. And enjoy. It's around 2 minutes. Basically, it's trying to show you how does it work, how to operate. I hopefully you enjoy it. It's really as simple as that, just to get the sample mounted, put it into microscopes, select the regions, and then a few minutes, 1 minute to prepare the result. Okay. All right, so I probably should skip this because we can come back to this if you want to know a bit more whenever you have a full project. I mean, in terms of storytelling, and then you have your idea and how to solve the problem, your prototype. At the end, people must ask, how can you make it a business, right? Business revenue model. So we might come back to this if you're interested at the very end. Okay. Sample testing. So where we were at now. So we have tested more than 100 animal samples who really have to respect the mice who sacrifice for our projects. And at the same time, we have been collaborating with primary hospitals, primary case of health hospitals, and also district hospitals for all those human sample collections. So thanks for their help. And we have collected more than 16 patients of samples already. And according, as I said, according to the images that we got, is image similarities between the two data sets as high as 95%. And certainly not very, the most important to push it to the next step is the clinical trial. I mean, large-scale clinical trial. So we have been working with the Prince of Wales and District and also primary to push this 10 times bigger in terms of the clinical size. I mean, sample size. We're targeting more than 600 patients in this big trial. Hopefully, we can get this done in around 2 years. Around 2 years. All right, so this is also very important. Whenever you propose something, you make sure you know what are the other options. I mean, competitors. Okay, so again, if you're interested, we can go back to this. But just one quick message is, for sure, I want to say good, or whatever thing that I'm trying to compare. Okay, for example, whether it's complicated, you need additional training, accuracy, speed, and also costs, everything basically. All right. The interesting thing about this journey, I can tell you, is every day you will learn some new thing. You step out from your comfort zone every day, and even us, so-called experts in our field, we don't fully understand or fully know what is the potential of our technologies. One of the medical doctors that have been worked with, next 2 to 3 slides I will show his face. He told me, hey Terence, yeah, the technology is very cool. You can do what we call the margin imaging. You remember our very early story, right? And they told me, but then not everyone got tumor. Okay, not everyone got tumor. Although cancer tumor become very, very common nowadays. But in terms of business, this market is not the biggest, and is indeed relatively small. And then he said that for the CHEM microscopes, the best place to land is actually biopsies check. How many of you know biopsies check? Difficult terms. No problem. So remember my case, right? I said if I have a tumor, what do? I go to medical doctors have a checkup. What do I do for a checkup? What does it mean? X-ray scans. What's next? Sorry? Okay, extract some samples. What does it mean by samples? And how to extract? This is exactly called biopsies. Biopsies is trying to get some tissue, that is your body's stuff, outside your body, get some samples. Yeah, just like what your friends said. Okay, how do I call you? Lloyd. Okay, so like Lloyd said, is to get some samples from your body and check it. Okay, this could really make CHEM microscope be the best platform for the medical applications. So he said, in terms of if we really want to consider this as a business, the business size certainly become 10 times larger. Okay, I'm not really making a joke. It's indeed, right? And before I go, one more thing is because cancer in general, people will say that it's something acute. That means it may not change every day for cancers. But there could be some acute diseases that you need to have this CHEM microscope to have a very quick result, hopefully as soon as possible. So that's why I also make this business size much bigger. All right, so with that, I believe I can give you the enough foundation that we start from margin analysis. And later on this year, we want to make sure that it also works for biopsy tissue. And in the future, we also incorporate AI diagnosis, a very hot term, into this system, such that to really work with the pathologists, make their life easier. I mean, release their burden. All right, so last but certainly not least, want to share with you is indeed a relatively young startup. Okay, so why do I say that it's young? It's less than 2 years old. We established this company around 2020 March. And with all the efforts from my team, I'm very glad that to show you we have lots of recognitions throughout these journeys. Many competitions, and also we have our own patent, and also press coverage. We also select to be the 12th MedTech startup to watch in the Information Asia Pacific. And as I said, we also recently joined HKUST in our program. I will share a bit more about this in about. Okay, so as I said, I myself serve as the founder, chairman, and chief scientific advisors of the company, covering the technology aspects. And Danny, a good friend of mine, is really covering the clinical aspects, making sure what we are doing is not engineers self-hyper mode. Because I can tell you in the old days, it's very common. Professors are very good at their own field. But whenever we step out from our comfort zone, we become just undergrads or even worse. This is something frank, to be frank, okay? I'm very honest. I cannot tell you that I'm expert in every field. It's impossible. So we really have to rely on Danny to cover the clinical aspect, making sure what we're doing is valuable for the medical profession. Okay, so as I said, the clinical collaborators involve clinical wells, primaries, and also non-district hospitals. And currently, with the help from UST and also I myself, the team members, we have some more private hospitals getting involved in this collaborative process. Hopefully, we can start this journey soon, not only in Hong Kong, also in the States and also China. I myself cannot do everything. I always emphasize that's why you need a team. Okay, that's why you need a hackathon, this platform to make friends, to know about your limitations. You cannot do everything. Trust me, no matter how smart you are, you cannot do everything. Okay, so without that, PhoMedics won't fly, although we haven't fly that. Okay, but we are marching towards the right direction. Okay, so Victor has been working with me for many years, at least like 2 to 3 years. Very personal lady and gentleman. And also Jesse, Oscar, Terry, who make sure everything is covered, I mean the remaining parts. So altogether, I think we have been covering most of the parts that is needed as a team. So by the way, those are just founding members. And this really concludes the first part, just the first part, I mean my journey. Okay, so as I said, I myself is I have a lab in UST. So altogether, this research team really supporting my startup company. The first one, PhoMedics. The second one, WePath. Probably I don't have enough time to go. And WePath is working on more AI thing. I mean, purely software-based. Seldom have too much hardware. But PhoMedics is positioned as developing hardware and the software integration to solve some medical problems. All right. Any question before I move to the next stage? No questions? How many of you are still with me? Is it difficult for my sharing first part, or is it still reasonable? Understand most of the parts? All right, good. All right, thanks for being with me and all your props up. All right, then so let's switch the gear to talk about this title. Okay, so if you are careful enough, you probably know this title is called Hey Innovators, Can You Make It? When you see Can You Make It, I don't know how you feel. For sure, it means can do it, right? Can do it. But at the same time, prototyping is really have something that you can see or feel or touch it, right? So this is also another side to look at. Can you make it? After the first sharing, I'm not sure whether many of you have this feeling. You must be kidding me. Hey, come on, you're professors, you have lots of resources. For sure, you can do it. If I were you, I could do it as well. Okay, don't find this as an excuse. Don't find this as an excuse. Let me ask you this question. I guess many of you know Elon Musk, right? Although you're not his friend, but you probably know him, Elon Musk, right? He's the founders of Tesla and SpaceX. Let me ask you to ask you a question. He asked you whether you know what you study in university. Don't Google. He asked you not to Google, okay? Don't Google it. How many of you know by your all normal or original knowledge, okay? You know what you study in universities? Physics. You sure? Physics. Just physics? MBA. MBA in university? No. That's master, right? Physics and what? Just physics? Don't Google. Physics. Okay. So you really have no excuse. Really have no excuse. For students who study in business, he's also a business student if you want to pause it too, right? Also studying economics. And for engineering students or science students, you have also no excuse, right? He's also studying science only. And also bachelor degree. And obviously not a so-called expert in any field. Right? But what he did, he showed that he can do a lot when he's surrounded by talents and also work on right problems. Okay, I really emphasize a lot of these right problems. Whether you're trying to solve a problem that is painful enough. Okay, painful enough. If you still don't get me, let me ask you a question. How many percentage of the startups actually died or got eliminated in the market because they are indeed working on something that is no market needs?
90%.
90%. Wow. Very wild guess. 25? 95. Okay. Wow. Okay, let me show you the answer first. So it's indeed the highest, but leave some room for other reasoning, right? So, although 90 is a good number to remember, or 95 is a good number to remember, but it needs many reasons that will make the startup not successful. And the highest, guess what, is actually no market needs, scale or not, right? It's not because we're not talented. It's not because we run out of cash, no money problem. It's that you're working on something that no one wants. Okay, so let me even give you examples. If you have a project, is someone that is very cool, okay, very cool, but no one wants to pay to buy your technologies or your service. Will you do that? Probably not. So how can you know your customers are willing to pay? Before you have a product, they cannot buy, right? What can you do? Market research, but you don't have your product. How do they know that? This is really something that they want. To a level that, oh, I experience it, I try it, oh, it's really what I want. I'm willing to pay it. Right? Oh. Interviewing stakeholders, it's a good approach, but it's not easy to have a very good sampling of the stakeholders either, right? All right, so this is really the miracle or magic of prototyping. You have to make it, let people try it, not only you. Be careful, not only your team try it out, you let others try it out. And also, stakeholders, users, they try it out. They will know what you can provide. And then at the end, you ask them, are you willing to pay this price with these features? And so that's why prototyping is so important. And make sure what you are trying to do indeed has a market need. This is actually a very scary number. Only 2% of the companies die because they are working on something that no one wants. Okay? And also make sure you know no one wants means what? It's not saying that your technology is not good. It's just saying that it's not good enough for them to pay. Okay? So don't work on a project that is like, good to have. Good to have may not, they may not win. All right, so innovators can make it. So as I asked, I already gave you the answers. How can you make sure people trust that when you are doing something and they need it, is welcome to the world of prototyping. And you really have to make it. And I like quotes, and at the same time don't overuse it, okay? But this one I really like a lot. If a picture worth 1,000 words, I believe many of you know this when you were a kid. But another follow-up sentence about prototyping is prototype is worth 1,000 meetings. Because meetings seems to be very good, but then it's nothing generating during meetings. You really have to spend your time doing the prototype, get a case study, and try to make something real. All right, so what's a prototype then? So a prototype is a simple experimental model of the proposed solution. And it's used to test and validate your ideas, design assumptions, and other aspects that could be quickly and cheaply. Because especially during this hackathon, you only have a few days. And this Saturday also is already your presentation day. Okay, so you really have to, all of you, I believe, for the one who joined hackathon, must be very proactive students. Must be very proactive students. So you have to think out of the box, find the cheapest way, quick way to realize your idea. Okay. All right. And what's the most important thing after all this? So that you can make appropriate refinement or possible changes during this test. Because no original product is perfect. Even if the one who are making money, those products may not be perfect. You must be finding a way to improve it further, or you can find a way. Okay? So prototyping is trying to bridge or bring these conceptual, vertical ideas into real, tangible thing and making them. Okay, as simple as that. So this is really the old way to do prototyping. If you are doing some app or software, trying to have this kind of like paper and stake it, next page, how can you do that? This is some old approach. Later on, I can share with you some latest approach, more younger approach that you can use for software illustration. So what is prototyping? It's indeed a very, very complicated process. What we call a non-linear process. First of all, we have 5 different stages. You have to understand the problem, define it, really make your idea, and then try to implement your idea with the prototyping. At the end, for sure, you need to test it. Although today we are talking about prototyping, but as I mentioned, it's a non-linear process, so I have no escape that I have to touch a little bit of each of these steps. Okay, so I'll go back to this slides later, no worries. So understanding the human needs, again, as I said, is the most important part. Why? It's because of 42% of the product ends up, or companies ends up with developing something no one wants. Okay? So in order to make sure you don't fall into this trap, you really have to gain or understand the problem that you're trying to solve. Don't think that it should be like that, and then you start doing it. It doesn't help. You really have to consult the expert. I mean, in that field. Don't consult like me and ask me whether that is, I mean, something out of my field. That doesn't work. You really have to talk to your users and spend your time observing, engaging, and understanding their needs before you really start doing that project. Otherwise, whatever you do may not be very valuable at the very end. And immersing yourself in the physical environment. So I still remember the date that I said I'm developing tools for medical surgeons, right? I always go to operating room, believe it or not, trying to see what they're doing and then what we can improve. You really have to spend your time in the environment that you are trying to solve that problem. You really have to go there. Okay, don't just listen. Whenever you see, it's much better experience. Okay, so at the end, you will also gain insight about whether putting your shoes in their position. to really know their needs, and so that you can really develop the tools that can solve their problem. And the second part is define. Okay, define is actually easier. After getting through that stage, you try to analyze what you observe, and try to synthesize them in an order, and at the end you propose some problem statement. For example, you should propose some problem statement that is human-centered. Okay, human-centered is important. For example, you have to make sure I try to improve their achievement by pushing the accuracies from 90 to 95. This has to be some achievement, and if it's like for sports, okay, then you have to make sure that something you can quantify and work around the human part. Okay, so such that at the end you establish some features, functions, and other elements throughout this process. So remember, the first stage is know about the problem, and this part is to think about what should be included in your product or service. Okay, you have to establish some features, functions, and whatever other things that you think is important in solving their needs. Third part, ideate. Creating many ideas in the ideation process. So start generating ideas. And ideas, be careful. All of you, although it's very young, but the world has been running for many years. What does it mean? Some people must have similar thought as you do. They might have already proposed a method to address some issue already. So why you to make the next billionaire, whatever. Then you need to do is to identify new solutions to the existing problems. Okay, you really have to think out of the box. The old way doesn't work. And you have to start looking for alternatives for viewing the same problem as well. Don't be tunnel vision. Professors is very good at tunnel vision, I can tell you. Because we're so good at something. And then no matter what we see, whatever problem we use our something to solve, it doesn't work that way. Okay. So don't tunnel vision, look for alternatives to view the problems. And remember this, keep getting more ideas at the beginning, and finally try all of them. Try all of them, and you will know which one is the best. You really have to implement them and pick some of, if not all of them, because maybe the list is too long, try more than one at least. Then you can compare your optimal one with the suboptimal one and see whether your so-called optimal one is still optimal. Okay? That's the best way throughout this process. And finally, we reach the most important part of today is prototype. Okay? So adopting a hands-on approach in prototyping. So what you're doing in this process is basically trying to produce many inexpensive and scaled down versions of your product. Why I say that is many, because as I mentioned, don't pick only one way. Okay, you have to at least have two, if not more, versions of the product to see if it's really pleasing. And the features are also equally important. Okay, I might go back to this later. The features are also equally important. So that you can investigate a proper solution generated in the previous stages. There are many different stages already. This is step 4, prototype. Prototype may be shared and tested within your team itself, perfectly fine. But remember, if your resource is available or your network is available, send it to other people outside the team. You will have heavy bias about your product because you have been, oh, okay, I have been working on this problem for so long. I know this is really the pain point. Don't tunnel vision. You are the expert doesn't mean that you are the good users. Okay, so let others want to trial your product and they will find out new problems that you have never thought of. Okay, so the features in the prototype are investigated and either accepted, improved, re-examined, or even rejected based on users' experience. It's like a loop. Okay, you thought this is the best, and they tell you, hey, this is trash, and you improve it or you abandon this idea. So this is a very important process. You have to make it, let people try it, If they like it, they may pay it. Okay, this is really the product and guarantee someone will pay the bill. All right. So finally, as I said, it's really the testing part. So you complete the product using best solution and during the prototyping phase. And these 5 phases, remember, as I said, although we can make them a separate box, as an iterative process. Okay, you won't say that, okay, one way, done. Then it won't be a very good product anymore. So you have to really redefine the problems and also keep improving, knowing how people think, behave, and do. And even during testing stage, you will have changes, alternation, refinement during this stage. Okay, something that you start remember, keep improving. For sure, work with the clock, work around the clock. That's also part of this hackathon event. Finally, go back to this slide. So this is very complicated process. You have to go back and forth. You finish prototyping, but you learn from prototype, describe new ideas, and even the test, you go back to it, have some new ideas, and back and forth, until it steps that, okay, so probably time pressure, I have to stop. Okay. All right. So go back to my case study or the journey. Still remember this, right? This is the like a rendering that we made for the check microscopes. If you unbox it, it looks like this. Okay, you may figure, wow, it looks pretty cool. Yeah, it looks pretty cool. Let's guess how much does it cost to build one in the lab? Yes, let's guess. Anyone want to have a wild guess?
3,000 to 4,000.
What's the currency? 3,000 to 4,000? I pay you 3,000. You think you want? No. Sorry? 200,000 Hong Kong dollars. Okay, I pay you 200,000 and you give me one. Any more guess? 20,000? 200,000. I already want to pick it. Huh? A million, not that. Okay, I give you the answer. 700,000. Okay, that's a amount. 700,000. So I can also tell you, although I shouldn't, the most important or costly part is actually the laser, the light source. Okay, the light source itself, the laser itself, costs us 300,000. 300,000. It's almost half of the cost of the entire microscope. So if you were the one trying to make it to a lower cost, what will you do? Correct? What will you do? If you know lasers is the one that is really contributing to half of the cost, yes, please. Perfect answer. Can we develop our own lasers? That's good. Could we have a team that is capable of cutting down the cost, make our own lasers, such that it will be much cheaper? Any other ways, apart from having our own team making the lasers? Any other approaches? No more? Mass production, yes. Because this question is tricky, right? How much does it cost to build one? Okay, for sure, as a business, you won't only produce one, right? You may go to 1,000, 10,000 microscopes they want to generate. Would it be possible when you go to mass production, it become much cheaper? You might say, any other proposed ways to cut down the cost? Wow, can we use other light sources to replace lasers? Very good, very good. Thanks for all the innovators' answers. At least in my case now, we indeed forget about the laser. We use LED. Okay, so there are many ways. First of all, there are many ways. Nothing will be only having one answer. Nothing. In real world, this will only happen in university education, high school, or whatever primary school education. Nothing in the reality will only have one answer. There could be better answers, indeed. Optimal answer also happen, but then won't be one answer. Don't stop thinking. Don't stop thinking. All right? Okay. Guess what? I said 300,000 for the laser diode. Lasers. How much does this cost? Does it cost for LED? You know? Sorry? 100,000. Like that kind of cost by 1/3, right? Seems a pretty good deal. But actually, LED is not that expensive. I can tell you in US, if we still order similar types of LED, it works around $400 US, like $3,000 Hong Kong dollars, right? Wow, really a big car. And I can tell you if I buy from China's some manufacturers, $10 RMB. Okay, so I'm just giving you some ideas to implement your ideas. Okay, don't be bound for sure. So by the way, don't get me wrong. Indeed, our technologies needs lasers. Otherwise, from day one, we will use LED already. But for sure, we have many tricks in terms of science and theory. We can use LED to replace it. Okay, but then in your case, don't shoot for the best equipment. Don't choose the best supports, whatever, to implement your idea. That's not prototyping. Prototyping, then whatever you have, you can implement them, try it out, spend time. Okay, basically. This looks very cool, right? But I can tell you in the lab it looks like this. This is like a 3D printed thing. Because after publishing our research paper, we really talk to our users. Because there's actually a big gap between research and translational commercial projects. If you have some research experience, you may know that, wow, in research, in lab, we have so many, I shouldn't say that we have relatively more resources. So we can buy the best equipment, have the most controllable manner, have very talented research assistant to help operate the device. But don't think that it happens in commercial product. The one who control the device might be our parents. Okay, don't expect they can be very handy to operate the device. No. Okay, so to fulfill our customers' needs, later on, we really do a lot of fine design, and you see, it's also very messy, right? That's general what's happening in the lab environment. All right. Still, I just said, wow, Terence, you must be kidding me. You said that is 700,000, right? The microscope. Even if you cut down, okay, forget about lasers. Zero cost, $0. It still costs me 400,000. Am I correct? Right? 700,000 cut down to 300,000 lasers. It still costs me 400,000. Don't limit your thought. Because I show you this prototype. I mean this one. This is the design I proposed. I guess many of you can realize what's this, right? Your friends, when you were a kid, Lego, right? How much does it cost to build things to support the light? Maybe $20 roughly. And as I said, these are all LED lights. Each of them may be a few dollars. And this system, what does it mean? Should be less than $10,000 and higher. For sure, we still have this part, right? Wow, this must be a lab level microscope. Then how about this? You really have no excuse. This is your smartphone. I guess all of you have. Am I right? Yes, all of you have your smartphone. And this is an adapter that you can put onto your smartphone and take microscopic images. I mean, you can see some very small, tiny cells of the lid or whatever samples that you put there. Okay, another guess. How much does it cost? It's a selling product, but it's not an advertisement. Okay. So how much does it cost? And what? $10. Wow, very close. $10 euro. But still less than $100 Hong Kong dollars. Okay, so another way to do it. I mean, a microscope. I mean, a phone with a more sophisticated support. This one may be 1,000 Hong Kong dollars. So what I want to bring you to this is that don't be bound by some ordinary design. If you work with this, I guess you're already amazed, right? You can use Lego to build a system. Don't mind. Prototyping is really testing your idea whether it works. If it works, it's a good prototype. Okay? No one really care about your appearance as long as it works. Okay? All right. So last but certainly not least, as I mentioned, there are indeed more modern ways to do prototyping for the software. Okay. This again, I did not take any advertisement price money for this platform. It's called Figma. This Figma is trying to implement your ideas in a relatively simple, but at the same time, it's more interactive, very colorful interface. And if you go to this website, then you can blend this idea and create prototypes that feels like a real experience, like this. So you can make everything connected and show press this button what goes next, like this. And then you can buy your product like this. Okay, all this you can use. The link is there. Can you see? Or you cannot. No problem. This is if you Google Figma, Figma, and then this will be the platform that helps you to illustrate some interactive software-based app idea. Okay. All right. So the final tips I want to share about prototype and product. And before that, I want to make a very clear statement because I don't know whether any of you are researchers. Okay, don't be offended if you're researchers because I'm also a researcher. Good research doesn't mean good business. Very important because it may not be profitable. Okay, as I mentioned, there are so many good to have projects. Good to have doesn't mean good business. Okay, many research are good to have. Oh, incremental, improving, but necessarily asking customers to pay. Okay, so that's why many good researchers might not be a good expert. And the final take-home message, something that we really ignore in research is about the cost, as I mentioned. We really are a little bit more resourceful. So if you want to downstream commercialize your product after your prototyping, okay, this is really after your prototype. You really have to think about in the long run, when it becomes a product, what's the cost? How much it needs to produce that device, and also in large scale production. Okay, one more problem about that lasers story, my story. Even if we are rich enough to pay that lasers 300K, lasers is very hard to large scale production, very hard to do. So it's beyond money problem. It's the possibilities of large scale production for your idea. Okay, and for sure, research we also don't fully work on. It's about stability. It could be okay, it works today or tomorrow it doesn't work. It's still good research or okay research. May not be good research, but still okay in terms of research. Commercial product, no one buy it. You sell it today, tomorrow you have no customers. That's it. Your end. So you have to make sure it's very good, very stable, very reliable, such that your customer really likes it, use it for a long time, and they will come back. So I believe I speak a lot, okay? And to be frank, I think I can have a much shorter sharing because you will go through whatever I said just now. If you start your journey, you will go through all of them. You will share the same pain that I have experienced. As I said, we are not, at least I myself, I never thought to be so-called boss, I mean entrepreneurs back to my old days. Getting a position in the university as an assistant professor is already I already spent all my efforts. I have to be frank. It's so hard to. It's really not easy to, especially because I relatively young, relatively young. So, but then, yeah, the VC call really changed my mind that I shared very early. Because researchers, being professors is good, but whatever we do are only on papers. We publish very good papers, very recognizable in the international stage. But we are not really the one who make real down the road. So I also want to do the one who can also drive the thing down the road. So that's why this is the part that I do. Okay, lastly is really the supporting scheme. That's it. Okay, because I was told that many of you might be interested in having your own startup later on in the science park, and just quickly share with you two things that I think would be beneficial. And ideation I may skip because ideation is something that you might get already if you win in this hackathon. And I put my time on incubation. So incubation is the place for you to grow. Okay, they will provide resources, they will provide maybe some network for you, and HKUST is really doing great. I really admit that. And in details, there are two biggest platforms. One of them is called incubation, another one is called incubio. So incubation, okay, I guess many of you are concerned about money, right? So incubation is providing a financial aid up to 1.29 million. Without taking any equity from your company. Okay, it's really generous program, but for sure it's not like from day one they give you 1.29. It's like a milestones. You reach some milestones, they'll give you another milestone, they give you. So incubation is a 3-year program, mainly for deep tech company. Okay, and the word into bio, I think the moment you see bio, you know that it's related to bio. Okay, it's more a medical paper program. So PhoMedics is under into bio. This is even more generous. It's a 6 million financial support, again, without taking any of your equity of your company. Okay, but for sure the bar is high. I mean, they really will screen a lot. Okay, so again, if you go through this path, you go through my pain, and hopefully you will also join on this program. It's indeed a very generous support program. Okay, so incubation is a 3-year program. Incubio is a 4-year program. All right, so really some information highlights. And with that, I probably should stop here. I don't want to overrun too much for my speaking. I indeed overrun for my speaking. I thought I should have 30 minutes Q&A. And yeah, and all the credits goes to the talents in my team. Okay, I myself cannot do everything, as I admit very early. It's really all the members' hard work to make all this happen. And feel free to ask me any questions. Thank you.
Well, thank you so much for the sharing from Professor Wong. So if you have any questions, so you can just feel free to raise up your hand. And if you join the seminar online, so you can simply type your question in Q&A. Thank you so much. Anyone, just feel free to ask Professor Wong any question.
Hello. I just want to know what's the biggest challenge during the fundraising process?
Wow, that's indeed a very good question. So first of all, because if I share, I never disclose any fundraising, right? As I said, although PhoMedics is like a 1.5 years old company, before that we already start preparing because of that call. I mean the VC call. I started about that. Wow, is it I should recruit a team to make this happen? And I start doing it. And I joined $1 million competition from UST to polish its idea and also subsequent many other competitions. And we are fortunate that in the first year of our competition, I think I've never disclosed this in other activities. We won 700,000 prize money in many different competitions. I talked to my team that we are not entrepreneurs. We are not. Let's speed up our process and progress. Learn from the judges. We joined many different competitions. I think the first year we joined like 10 competitions. And I'm very glad to share with you, I guess we won 8 to 9 of them. Yeah, so we secured $700,000 money. And to be frank, it's not enough. It's not enough, especially for a medtech company. And actually last year I tried to raise the money. And the first hurdles is the team. We're not many investors. So yeah, even I myself, I mean, to convince others, although I have a professor's title, I'm still young. But when you talk to some very senior CEO, whatever. So this is indeed one challenge. I mean, for team, my team is relatively big. This is one of the biggest challenges. Hopefully I answered your question. So this problem will be more severe for all of you. Yes. Yes, please. Thanks.
What I saw is the pretty complicated. And for your research, maybe we're only working on AI for and how to turn this very complicated product will like the option parts because we are not specializing. I don't know this. You are not specializing everything. Every time this in my situation is I'm also working on research. However, that part of research is in part of area and really apply a great value to the reality. Actually, it has anything that's and I need help that thing how can this work?
Very good questions. So thank you first. First of all, let me declare myself first. I'm actually a more optical design person. I work on optical system design and also build the systems. This is the part that I'm good at. To be frank, like 3 years ago, I'm not an AI person. I'm not. I start from zero. But this is not skills. Again, even those AI experts, I tell you, nobody tells you, all those AI experts, they only start recently. Because why they only start recently? Because of the GPU's development. In the old days, people use machine learning. And I can also guarantee you that when people say that well, they like AI, they mess on AI, they don't know what is AI. To be frank, they never know. When they mess up machine learning, deep learning AI, they don't know AI. They don't know deep learning. Yeah. So to answer the question, you will never cover everything yourself. So that's why I keep emphasizing many times within the team. Okay, so taking my story as examples, I'm good at building systems. But in the early days, I'm not an AI expert. Then I work with so-called AI experts. Learn from them. It's okay to learn, but it's not okay not to learn. It's okay that you don't know, but it's not okay that you don't learn. You keep learning. Even professors, we learn every day. We step out from our comfort zone every day. And as I told you many times, we are not experts in all the fields. Even for so-called professors, we cannot. Not to mention students, right? So admit that you don't know, not a problem. Work with someone that can cover your limitation. Then this is what we call the team. Hopefully I answered the question.
Life will be very dark. And this book is developed by kids. One day, this of your response. Now, I just want to advise.
And
we don't have the response the university.
Yeah.
Which
Yeah. So first of all, I can break this question into 2 parts. Whether you have already identified a certain person who can help, but you don't have money for them, or you even don't know whether who is he or she. So let me assume is the first case, is that you actually know this person, but you don't have the resources to pay him or her. Then the easiest way, guess what? They can equity. Work with you. because they're important. From what you're expressing is that this is the part that you need in your team, right? If it's something that you need in your team, I can guarantee you that will be a long-term investment. And get them involved, give them equity. That's one way to solve. For sure, if you have money, then like contract, right? Service contract, that is a separate story. But if you think that that's important in the long run, ask yourself whether it's the short term or in the long term. If it's long term, this person skill set is something that I need, get them involved, give them equity. Yeah, hopefully I answered. Yes, please.
Hello, thank you, Terence, for your presentation. Very good. I would like to ask about some fundraising problem, mainly about VC. First of all, I have two questions. The first question would be, have you already signed any contract with any VC? And my second question is, if you didn't, how do you find, how do you approach VC? And do you have some VC contract on hand comparing? If yes, what are your main considerations on those contracts? Thank you.
All right. So yeah, thanks for your question again. So many of you already in the VC stage. Okay, it seems it's a prototype stage. To be frank, previously I have finished one due diligence with a VC, but it turns out we did not close the case. It's because they internally find out they have financial crisis in their own company. Seems that the VC is even more poor than a startup. Okay, so to answer your question, this is we don't have a contract on hand, but we indeed are talking to many different VCs now because this is really the year that PhoMedics need to raise. To be frank, we actually want to close last year, but as I mentioned, we actually go to a point that we can close, but it turns out they have some problem, so we have to find a new partners to work with. And this time, likely we have been talking to, I think until now, I guess 15 VCs, and you are asking me about the sources, right? So are you a university student or?
I graduated from CHK and I have my company now. I've entered science park incubation program.
I see. So you're in the incubation one. Okay, I see. So VCs, then if you're in science park, the first one that you can rely on is the science park investment team because they do have in-house investment team, right? So this is what you know. They could invest not internally, and they will also link you to other outside companies and VCs. That's what I know because they have been introducing me 6 companies from science park. So that's why I also can tell you a little bit. And for sure, part of leverage what you have in CHK. Because in UST also introduced like another 6 VCs for me, and outside I also contact. Because whenever I share something outside, there could be some sudden VC pops up, could have. So it's also visibility problem. So if you have ways or chances to talk to audience, bigger seminars, especially roadshow, some like startup roadshow, if you have those opportunities, go there and see. Because I can tell you, whoever presenting, don't aware of that there are many VCs listening. There are indeed many VCs. I tell you more, although entrepreneurs like to find VCs through different means. But you guess what? The VCs try to catch good project as well. Don't think that is one side, it's actually both sides. Roadshow is a good platform. Okay, hopefully I answered. Sorry, keep going on. I don't know that
One quick follow-up. Sure, very quick. Because you have mentioned talking to some VC, I'd like you to explain more about talking to the process because I have not yet reached somewhere close to closing a deal, but I have really talked to, but never mentioned any contract. But can you a little bit more about the process? Thank you.
I see. Yeah, sure. So first of all, there are 2 categories of VCs. The first category is more traditional one. They will give you a term sheet. So term sheets would be, okay, I give you, you give me X% of equity, and I give you this amount of money, and I hope that in 1.5 years you raise again. I mean, another round of fundraising, such that I can exit or whatever. So normally we will have this timesheet. Okay, after this timesheet, you really want to know a bit more about their company and whether so remember, don't take everyone's money. So although money seems to be money, right? Why not take it? Because if you have a choice, if you have a choice, take someone's money that who can help you. Okay, remember this. Beyond the money. So let's say I am Terence, okay, obviously, okay? And Science Park and Terence want to invest on you. Guess what? Which you pick? Exactly. Choose the one who have lots of backup resources who can back you up. I could be a very rich person. I said, okay, I can invest on you. Don't take my money. I may be only rich person, but I have no backup on my back. Help you throughout the way. I cannot. So if you have a choice, also be wise to choose whose money to take. Yes. So timesheet, knowing about the one who only invest on you, and finally, you likely will do due diligence. Due diligence is a process that making sure you are really you, they are really they. I mean, making sure like the financial report are correct, everything that should be no fault in between, and then at the end you close the deal by signing all the contract at the very end. Okay, roughly, this is the first category. The second category would be very different style. They probably won't give you timesheet, and then roughly give you idea. Okay, this amount of money I'll get you this share, and then sign. Why do we have this kind of leases? Because they're too rich. I'm not a joker. They're too rich. They might have some historical mission to spend the money. Yes, they could have some leases like that. Okay, so mostly two, but the first one is the majority. They'll give you a term sheet, and they start discussing more, and finally do the due diligence and seal the deal. Okay, all right. I thought this.
How you talk about the microscope that's the prototype? How to get through the regulation hurdle?
Wow, thank you for the question. Indeed, we learn the lessons. Do you know medical device got different classes? How many of you have some idea, right? You know what? Even I myself, again, we call so-called maybe expert in imaging. I don't know which class it is. I don't know. This is like a governance issue. In the old days, there's a third-party contract research organization. It's like a third party to test your device, making sure it's a good product, and then you can get a certificate right afterwards. They said that we are class 3. They said that we're class 3. Class 3 is the highest class, and then normally the clinical trial will take like 3 years. Okay. Guess what? After 4 months, we found that we're class 2. We got food. Okay, so don't fully trust whatever people would say. For sure, we have lots of other support later on to say that it's really class 2. So why I have to say this, you need to know what's your class first. Because if you know the class, then the life cycle will be very different. Guess what? How many of you know pharmaceutical company? You probably know this term, right? Pharmaceutical. That means the company sells drugs, medication. The life cycle is super long. Easily like 5+ years or 8 years before you can sell the first drug. Okay, so because they have different phases. And in medical device, in general, for our case, like class 2, it only takes 1.5 years for clinical trial. Okay, so that would be hopefully I answer some of your questions regarding regulatory. About 1.5, we should be able to get the medical certification. That's why we need to raise the money this year to make sure we speed up the process. Okay, because we have to pay in order to get the certification. Okay, any more questions? Do you have any questions on Zoom?
Not yet.
Not yet.
Okay, if there's no more questions, then I think we are about time also. So big thank you to Professor Wong.
Thank you.
Thank you very much for your sharing. And thank you very much for joining. And hopefully you pick something and start keep working on your project. And I look forward to your presentation and PowerPoint this weekend. Thank you.